Now, there are two different methods in order to solve side lengths and angle measures with general triangles. One of those ways is the law of sines, and one of those is the law of cosines. We're going to be looking specifically at the law of cosines, of law of sines in this video. Okay, like I said, this is a general triangle, does not have a right angle. So because it does not have a right angle in it, you cannot use SOHCAHTOA. You have to use either the law of cosines or the law of sines, depending on what measures you have. Oh, sorry. Before I can get to an example, I need to actually tell you what the law of sines is. The law of sines is the sine of angle A over little a equals the sine of angle B over side B, which equals the sine of C over little c, in which we know the capital letters are angles and the lowercase letters are sides. So if I were to draw a general triangle here, now remember the sides match up to the angles because they are opposites of the angle. So with that being said, let's go ahead and look at an example now. So if I have triangle A, B, C, angle A is 49, angle B is 57, angle C we're not sure, little a is 8. Now, I like to set it up that I have all my angle measures and all of my side lengths listed out, not necessarily on a picture. To me, that way I know I've got everything. I don't know. It's just something about me. Okay, so I've got 49, 57, trying to find it, and 8. Okay, well, to start off with, the angle is probably going to be the easiest. And I say that because we already have two angles, and we know that the total degree measure in one triangle is 180. So from there, I can go ahead and just subtract in order to find angle C. So if I were to go ahead and subtract that, I know that angle C is going to be 74. So that one was probably the easier one that we could have worked with right away, but this is going to help us in the long run to find side length B and side length C. So with our law of sines, we know that it's sine A over little a equals sine B over little b, which equals sine C over little c. Now, currently, I only have one side length. So I know that I have to use this sine A over A because that's my only side length I have available to have a full set. You have to have a full ratio in order to use the law of sines. If you don't, then you're going to have to use the law of cosines. So that's something you need to realize. I need to have at least a matching side and a matching angle to go together to make a full ratio. So now that we've kind of gone through figuring out, okay, I've got my full ratio, I'm going to go ahead and go with sine 49 over 8 equals the sine of, we know angle B is 57 over little b. So when I'm doing this, I need to solve for it algebraically, just like I normally would any other type of algebra problem. I'm going to multiply both sides by b, because we know that's going to cancel the b's out. So now I've got b times sine 49 over 8 equals sine 57. Therefore, I'm going to divide then by that sine 49 over 8. Which, when we type that right into our calculator, it's going to calculate it for us, and we're going to get a measure for b. When I type that in, I'm going to get a b measure then of 8.9 approximately. So now I can write that in up top, 8.9. I'm going to go ahead and work to find c. When you're doing this with your law of sines, it's best if you stick with the same ratio. So I started off with that sine 49 over 8, so I'm going to use that sine 49 over 8 again. I don't necessarily want to intermix the sine 57 over that 8.9, and the reason why I say that is because we rounded that answer where we know for sure we have a definite 8 value. So that's why we want to stick with that same one so everyone is on the same page. So I've got sine 49 over 8 equals sine 74 over little c. Now, if I'm looking at this, it's basically the same setup. So I'm going to multiply by that c to both sides because it's going to cancel on the right. I've now have sine, or c times sine 49 over 8 equals sine 74. Therefore, I'm going to divide by that sine 49 over 8 to both sides. And when I go ahead and calculate that, I am going to get c equals 10.2. We know that these cancel and these cancel. So these are my final angles and side measures using the law of sines. Now again, in order to use the law of sines, you need to have an angle measure and its side that match up in order to set up one ratio. The real reason, I guess, why I put all of this at one side is that it's easier to look at and grade because it's all in one spot. Otherwise, you can, depending on what we talk about, generally, if we're working with angle measures, round those to the nearest degree. It just makes life easier. Side lengths, you can round it to the nearest tenth or nearest whole number. It just depends on what I'm looking for specifically, but I will let you know.